So first thing today, reviewing some of our unit multipliers because we will need those as we are finding something new, something called angular velocity. So first thing I want us to do is to review these unit multipliers that should be very familiar to everybody, with the exception of the one with the star. It may be new to some students. Many of you will have already worked with that one in your science classes, but for some of you, that one with a star may be something new. So let's review these and fill them in. And so inches and feet. Casey. So 12 inches in 1 foot. I have all these plural, just I'm not giving anything away there. Gina, next one. So 3 feet in 1 yard. Feet and miles, Aiden. Okay, centimeters and meters. Now we're doing some things within the metric system. How does that one work, Ava? And that works the same if we're talking about liters or grams to centiliters in 1 liter, centigrams in 1 gram. What about liters and milliliters? How does that one work, Maya? And again, same thing. 1 gram is 1,000 milligrams. 1 meter is 1,000 millimeters. Okay, how many of you, raise your hands, have done the next one in your science classes? So that is most, but not quite everybody, and that's fine because it's going to be an easy one to learn if you haven't seen it before. Jack, what is it?
1.
1 what?
Milliliter equals 1 centimeter.
Not equals 1 centimeter, but 1 cubic centimeter. So we're thinking about, you buy Coke in your 2-liter bottles, so that's 2,000 milliliters. If we somehow took just one of those 2,000 out of your 2-liter bottle, and then if we thought about a cubic centimeter, centimeter by a centimeter by a centimeter, that would be the same amount. Okay, then centimeters and inches is our important one because that's the only one we use for going between English and metric. Chloe? 2.54 inches or centimeters? 2.54 centimeters in 1 inch. If you get that backwards, a centimeter is about this big, an inch is about that big, about 2.5 of those fit together to make that work. And then the last two should be super easy, so everybody shout out seconds and minutes. And so everybody good with those? Okay, let's do an example that has that milliliter thing in there on this one. So I need to take liters, and I somehow need to get to inches. So one thing that I'm going to have to do in there is to go from metrics to English. So I'm going to have that 2.54 thing in there somewhere. But before I can do that, I have to be able to get to centimeters instead of liters. So I'm going to have to use that new one in there, that cubic centimeter milliliter thing in there. I've got liters, so it looks like the first thing I'm going to have to do is to get from liters to milliliters. Would you guys agree? I'm kind of trying to model for you guys the thought process going through that. So we write down the one that we have to begin with, and that goes in the numerator. Okay, we're going to change that to milliliters, so I need to get rid of liters. And what does this multiplier need to be, Abby? 1,000 what? Okay, so I'm going to put the 1,000 milliliters over 1 liter and mark out the liters. So now I get to use that new multiplier. I can say that 1 milliliter is how much? 1 cubic centimeter. Now I need to change the centimeters to inches. So I need to get rid of the centimeters and have inches instead. Kinsley, what's this multiplier? So the 2.54 in the denominator with centimeters, and that's an inch, except this was cubic centimeters, so I need 3 of these multipliers. If I have this cubed, that means the 1 is cubed, the inches is cubed, the 2.54 is cubed, and the centimeters is cubed. So the centimeters cancel out. I require you guys write this in clean form. Too many of you have sloppy handwriting, and it's very hard and time-consuming for me to look through with all of these things crossed out. What should you have been putting in your calculator? So clean it up and write down exactly what's going in the calculator. So if you don't get it right, I can easily see where the error is. So numerator, it looks like I've got 25 and 1,000 and some ones and inches cubed. Denominator, it looks like I have some ones and a 2.54 cubed. Is that everything? Did I miss anything there? And some of you have got your calculators out. So Sophie B, you were punching in a minute ago. What'd you get? Did you do 1,000 or 100 when you entered that? Everybody good with that? So any questions there? Okay, now some of you guys and girls into cars at all? What does it mean when they talk about RPMs? Some of you have that displayed on the dash. What is that talking about, Sophie? Rotations per minute of? Okay, so maybe the gears and how fast they're shifting. I'm not an auto mechanic, so I'm not real good at this. Somebody else? A little different variation on that? How fast the drive shaft went? What do you mean by moving?
Like how fast is spinning?
Spinning is the key in there. And I've heard it said revolutions per minute, which is where the revving the engine comes from, making it turn faster, but that means exactly the same thing as rotations. That is an example of angular velocity. Angular velocity is how fast something is spinning, how fast it is rotating. It is technically a vector, so it has direction and magnitude, but we're going to be talking about measuring it in some unit of circular measurement per time. So we may say revolutions per minute, second, year, whatever. We may say rotations per. We may say radians for how far we're spinning around, or we may say degrees. The numerator will always be degrees, radians, or revolutions, or rotations, because those are synonyms. Over some unit of time, these are just examples. If we start talking about planets and their orbit around the sun, we may be talking about revolutions per year, or something like that. So any unit of time in the denominator, but some way of measuring how far it turns, how far it spins in the numerator. And we're going to have a new formula for how we calculate angular velocity, or how we convert between linear and angular velocity. So if you think about going down the highway, your speedometer displays what? What are the units on your speedometer? Miles per hour, and is that measuring how fast your car is turning? It's measuring straight line, how fast you're going down the highway in a straight line. But is there something on your car that is spinning that makes you go down the highway? The wheels, the tires are spinning. They will have an angular velocity. They go around a certain number of times per minute, second, whatever, to make the car go down the highway a certain number of miles per hour. So this formula is the formula that relates the linear and the angular velocity. V is the linear. It is in linear units, straight line. So things like miles per hour. This next letter is not a W. It is the Greek letter omega, and it means the angular velocity. So the linear velocity is going to be how fast something is spinning times the radius. But there is a catch on this. The angular velocity must be in radians per time. Cannot be in revolutions, cannot be in degrees, must be in radians. So if it's in revolutions or degrees, we have to convert to use this formula. And if we just use the formula to find omega, it will automatically be in radians unless we convert it. So since we're going to be doing some converting, the equivalence that we're going to need to remember is 1 time around the circle. Going around once is 1 revolution. And we know in radians, 1 time around a circle is 2 pi for how far we've gone. Radians are going to be a freebie unit. Normally we don't write when we're labeling our unit circle pi over 3 radians. We just say pi over 3. Radians we can write in or we can cross out as we need to. And just as soon as it looks like everybody has that formula copied down, I've got 2 examples we're going to go through together. Looks like we're good. So this is what I just said. If it's in revolutions or degrees, you've got to convert it, and we can write in or cross out radians as we need to. So let's suppose that we have a wheel, it's got a radius, it's spinning. We are being asked to find how fast the wagon is moving in miles per hour. So they want us to find V, omega, R, what are we trying to find? We're trying to find V, something that's in miles per hour, that's straight line distance per time. So we want to find V. So we write down that our formula is V equals omega R. And then we start filling in what we have. So we know that the radius is 18 inches. So we're going to have some omega times 18 inches, and we do need to put our units in there. And then spinning around 30 revolutions per minute. So far, everybody with me? But the catch is I can't use this formula unless omega is what? What, Maya? Radians. Are revolutions radians? So we need to convert that. So we need to get rid of the revolutions. So we need those down in the denominator. And so, and then I need radians up here, which I don't really need to write. I'll put that in just for emphasis. So what numbers go in that multiplier? Catalina? Where? Numerator, denominator? Numerator are 2 pi radians. Is that all right? So 2 pi for radians is the same as 1 time going around. So now I have this in, and I don't really need the radians in there, inches per minute. Now this is just a regular Algebra 1 unit multiplier problem. We had to change the inches to miles and the minutes to hours. Does not matter which one you want to do first. So let's see, Avery, give me one multiplier I could use to start changing one of those. Okay, so if we get rid of the inches, we use 1 foot over 12 inches, cross the inches out. Now we have feet per minute, and let's finish changing the feet to miles. So what am I going to need there, Natalie? Little louder for me, please. Okay, so 1 mile over 5280 feet. So now I have miles per minute. And what do I need to do to change the minutes so that I end up with hours? Ryan. Since these minutes were in the denominator, I need minutes in the numerator to cancel out. 60 minutes is the same as 1 hour. Radians was the freebie, so I don't really need it in there. Clean form. 30 times 18 times 2 pi times 60. Is that everything for my numerator? Other than miles. And my denominator, 12 and 5280. And hours. Did I get everything in there that I needed to have? Make sure I didn't skip any. Punch it in calculators for me then. Ryan, what'd you get? You're starting to write. What'd you get when you punch that in? Well, go ahead and put the pi in. Anybody else? 3.213 miles per hour. We good with that? And no, I'm not going to, on these, ask you to do it with simplified pi answer. Okay, let's do one more. So, automobile, wheels, it's traveling. We want the angular velocity this time. So, if v is omega r, we want the angular velocity. So, first thing we're going to do is to rewrite our formula. So, omega is v over r. Do I know v on this one, Al? Well, I've got 28 inches in diameter and I've got 60 miles per hour. So miles per hour, that's straight line. That's not a spinning around kind of velocity. So we're going to put that in for our linear velocity, 60. Do the miles over the hours. Do not use MPH when you're writing it out in multiplier form. Do not use a slanted fraction bar. Use a straight horizontal one to make it easier to see what needs to go where to cancel out. So change that so it's miles over hours like this. Okay, so I've got V. I also need my radius in the denominator. What is my radius for this one, Ayla? Since the diameter is 28, the radius is 14, so we can put that 14 in the denominator along with inches. So that's our angular velocity. It's going to automatically be in radians. They want us to get it in revolutions per second. Well, we have hours in there, but we've also got miles and inches. Tell me something about miles and inches. What do they have in common? They're both units you might use for what? For distance. So there are two different ways of measuring distance. So what we want to do is to have enough multipliers in there to make them both cancel out. So let's do that part first. I have miles and inches. I need a multiplier that will start to get rid of one of those. So Grace, give me one multiplier I could use to start to get rid of the miles or the inches.
To get rid of the miles, you divide by, multiply by 5,180.
Okay, what I would do is if I want to get rid of the miles, I'd put miles in the denominator, feet in the numerator, so I would multiply by 5280 feet over 1 mile. Now I have feet and inches. Billy, what multiplier should I use to finish getting rid of feet and inches? Since inches are in the denominator, I want inches in the numerator. And so 12 inches in 1 foot. So now I no longer have any of those linear units in there. Okay, right now, since it doesn't say, this is automatically in radians. I don't want radians. I want revolutions per second. So what's this multiplier? What does it need to be, Morgan? And so now I've got the revolutions that I need, and I didn't have to have radians in there in the first place. I just wrote them in to help us kind of figure that out. So now my only units are revolutions per hour. What do I need to do to change the hours to seconds? Kian.
60 seconds equals 1 minute.
Oh, we're going to get there in a minute, but let's try to get rid of the hours, which are in the denominator. So what do I need to multiply hours and? So 60 minutes for my denominator is the same as 1 hour. Now I have it, revolutions per minute. So what is the last multiplier that I am going to need to put in here? Ariel? And let's clean it up. What all do we need to put in the calculator this time? 60 times 5280 times 12. And that will give me revolutions. And in the denominator, 14, 2 pi, 60 and another 60, and those will be seconds. I think I got all of them in there. Did I make sure I didn't miss any? And punch it in the calculator to help me out. And Elizabeth, what do you have? So any questions on this? And I have some work for you guys to do.